today's video, we will memorize the reaction mechanism of diazotization, which is converting an amine into a diazonium ion, aka N2. First step is a nucleophilic attack. So we have an NO2 ion created from this. Make sure that your reaction condition is in the cold, between 0 to 5 degrees. So that will give us a positive charge on this nitrogen, and this double bond stays. So we don't want the positive charge, so we use water to eliminate the hydrogen, which gives its bond to nitrogen. And here we get N-nitrosamine. This group, N-nitrosamine. Okay, now we want to get rid of this group and make an alkyne here. So two ways to do that. The first step is to protonate this oxygen so we get a good leaving group. And the second is, in order to put an alkene, or eventually an alkyne, we will use an E2 elimination using water that attacks the hydrogen, which gives its bond here and removes this leaving group. Well, doesn't remove a leaving group yet, but we do make this alkene into an alkane. So far you'll know you're on the right track if you have a double bonded N and one alcohol. But now we want an alkyne here. So what can we do? Well, because there are lone pairs on this nitrogen, this can donate to form an alkyne, and then this bond then will break. But actually a better way to do that would be first to protonate that alcohol so that it becomes a better leaving group. Okay, so we just protonated this. Now that it's a good leaving group, we can put an alkyne here and this bond will break off. So that is how we get diazonium ion. Formal charge here is there's one positive diazonium ion. So major takeaways for this mechanism is you will often use water as a base. You'll use it twice, and once you get this important intermediate N-nitrosamine, then we will protonate the oxygen twice so that it becomes a good leaving group. And in the first alkene, we use water to make an E2 elimination, and in the second time when we want to make an alkyne, we use the lone pairs as the electron source.